Knoxville Game Design, October 2018. Artificial Intelligence with Joe and Levi.
Welcome everyone to Knoxville Game Design for October 2018. We are developers in the Knoxville and East Tennessee area. We get together once a month to talk about our game projects and topics in the games industry. This month we currently have myself, I'm Levi Smith in Oak Ridge, Tennessee, and we also have Joe Miller in Morristown, Tennessee.
Hello.
So I guess I'll go over a little bit of the news real quick. Share out my screen here. And first of all, I wanted to mention that I occasionally check out the referral traffic to knoxgamedesign.org, and I've found out that we're listed on this Knox podcast network and a couple of other places, but they have a area here for games and hobbies, so we appreciate them linking to our site and our monthly podcast. Also this month there was Siege or SiegeCon in Atlanta, is in the northeastern near Marietta area. Joe, you didn't go to Siege, did you?
No, I wanted to. I just couldn't work it in the schedule. We need to plan around it a little bit more, I think, for next year. October is really busy for me with the day job too, so it's
Yeah.
I wouldn't have been able to take time off.
Yeah, it sounds like it's a good conference. I mean, they had a couple speakers, like the guys from Extra Credits, I think, spoke there, and indie game developers. But yeah, it's in actually Marietta, I think near the new Braves Stadium, so you don't have to go to downtown, which is kind of nice. But it was 4 days, and I think they didn't have individual day like tickets. So it's like something I wouldn't mind going for a day, but I don't know if I want to, like Joe, you're saying, like take off a couple of days from work to go down there. But looks like a lot of good talks. And I think they may had a convention floor too, maybe, because we spoke with Zane Everett. He stopped by during the CreepyCon event to our booth and invited us to come to Siege. So, yeah. So I'm kind of hoping, yeah. So yeah, maybe something I'll do in the future. I'm not sure. We can look into it. Also, coming up pretty soon, Joe, are you doing GM48?
I'm gonna try. I got most of next weekend clear. It's Community Day in Pokemon Go, and we still play that. So
okay,
on Saturday, but it's only for 3 hours. So I could probably still try to come up with something. Then I'll see what the theme ends up being. I've got a couple ideas for jam games that I could try.
Yeah, I'm thinking about it too. I think my weekend should be open, but yeah, so it starts in 5 days next weekend. So second round, I guess the voting is going on right now.
Yeah, so the first round was last week where everybody was submitting themes, and now I think it should be voting on the top 10 maybe would be what it's down to.
Yeah.
Not sure how they're...
Here it says theme second round, October. I don't know if that's the start date or the end date. Start in October. No, that's the actual dates of the jam. Yeah, I'm not exactly sure. I guess vote right here. I'm going to go ahead and log in here. So they give you individual themes. It's kind of like the theme slaughter in Let 'em Dare, I think.
Yeah, it should only be, since it's the second round, there's not going to be very many. The first round had about 150 or so.
Mm-hmm.
So it's not quite as big as Theme Slaughter. You can sit through and vote them through pretty quick, and then the second round I think is like the top 7 positive ones and like the top 2 most controversial ones and 1 funny one or something like that.
Mm-hmm.
I think he has the guide somewhere for what makes it through to the second round.
Yeah. Yeah, this is actually it's actually pretty cool. So they give you one theme at a time. You can either vote downvote, upvote, or say that it's funny, and it gives you a listing of everything you voted on so far. And I guess if you mess up, you can delete a vote.
Yeah, so you can revote if you change your mind.
That's pretty cool. Yeah, I've never actually done voting for GM48 before. So yeah, anyone out there, game developer or game maker developer, GM48 is coming up this weekend. And also, as usual, we have Ludum Dare coming up. So this will be at the end of November. I think this will be our regularly scheduled 9 p.m. kickoff, or that's when the theme is announced. I guess we can get together like at 7. I'm not sure if we want to do Token again or go back to Panera. I mean, it's up to
It's
you
like
guys.
the 1st of December, right? Or-
Yeah, I think it starts like November 30th.
The Friday? Okay.
Yeah.
Yeah, I think last year it was more towards the end of December, I thought.
Yeah, it seems like it's definitely in December sometime.
Mhm.
I think some people might have complained that it kind of conflicted with final exams for colleges and high schools and things like that. So maybe they moved it around. But I know next year they're moving just to 2 events a year. So that'll reduce the number of
Next
times.
one will be in April.
Yeah, I think they're going to like April and August or something like that. Okay. Yeah, I was just going to mention Unity. It seems like they're like releasing a lot of versions of Unity lately. They're coming out with a new version like every week. They're like minor versions, but it is kind of annoying every time you start Unity that it tells you to update. So, yeah, I don't know if they'll have a way just to like only accept major releases. I was going to mention on my website, I developed a tool for tracking Unity versions, and I actually made a post about it, how to use it and everything. But it will scan through a directory of projects and find all the version numbers and tell you if you're out of date. And it also lets you compile for various platforms, including WebGL, which is kind of why I developed it, because there's no way to automate that before. Yeah, so Joe, I saw you've been doing a lot of work on your RPG, your tactic style game.
Yeah, well, right now I kind of actually put that on pause for October. I was trying to participate in Devtober, which was like a month-long game jam sort of
Mm-hmm.
to make and release a game in the month of October.
Mm-hmm.
So I've been doing another little project for that. But the still been working on the strategy RPG too, which I've gotten a lot of progress done on the battle engine, and it is almost functional. So I'm getting to the point where I'm having to write a decision tree for the enemies when they take their turns,
Oh, okay.
which I think was something you had for the topic today.
Yeah, I was going to talk a little bit about that. I don't claim to be an expert.
Well, the first time I've done it, so I'm just kind of making a bunch of nested if statements and trying to decide which way something would go. So it's kind of like an AI, but it's still really just.
It sounds very AI to me.
Yeah.
But yeah, I see you got your
Yeah, so
animated GIFs.
for the
here.
Devtober, I was doing a tower defense game, which I've never done as a genre before. I've thought about it for game jams, but it seemed like a lot of elements that I hadn't really messed with. So I'm kind of enjoying using this one and figuring out pathing and what kind of, I guess not really, trying to like do how the towers know when there's enemies near them and like which one is most further along, so it should attack in what way, and then trying to develop a system of the waves of enemies at the same time.
Yeah. So Devtober, is that something? Is it just on Twitter, through Reddit, or is there a website for that?
Twitter is where I saw it.
Oh, okay.
Don't have the name of the guy that started it. It sounded like he just used the hashtag randomly and ended up getting a lot of people in support of doing it, like around September 28th or so.
Mhm.
And then it's just been people using it on Twitter that they're working on stuff for it. But it didn't have to be stuff that was purely on October, and there's really no rules about anything about it. It was just that you're devoting time in October to working on your games.
Yeah,
and then sharing the progress, which I've actually been pretty bad about it because I've missed like the last 4 days.
Oh.
Back on track today. It's been.
Yeah. That sounds very cool, just because I know they don't do the mini LDs. I used to do that every month. I know they still have one game a month around, which I think I used up all my slots on that. But it is very cool to see like a game jam like come up organically. I know if you go to Itch.io, then they have a lot of jams out there. Anybody can create a jam, but it's like nobody's really signing up for those. And there's just so many of them out there.
Yeah, and I was just trying to use it to do a genre that I hadn't done yet, and that was tower defense, and not really planning anything special about it. It's not particularly unique. It's just I've not made one, so I wanted to see some from how the other side just yeah, I think that a lot of my early games were just copying other games too, just to see how it is to program it from scratch.
Yeah, your voice just went a little bit mute there. Oh, there
sorry.
you go. Yeah, yeah. I always like trying new things and doing different game types and things like that. Yeah, since you mentioned this Devtober, I was going to mention Dylan. He's not able to join us this month. I think he's going to be back next month, and he may or may not be doing like an intro to game development talk. Oh yeah, and by the way, DevSpace, I think that was this weekend. Maybe Dylan is at DevSpace, I'm not sure. Maybe he's talking there. But he's been doing Inktober, so that's kind of like art related. So it looks like he's doing a new picture like every day, like in ink, and he's like really made some really nice artwork here. I could definitely see this being used in a game.
Yeah, I've got a few people on Twitter that I follow that are doing Inktober. I think that's been a thing the last couple years.
Yeah, that's the
I've
first I've
seen
heard of it.
other hashtags too that people. I mean, there's like Righttober and whatever, where you're just basically doing whatever it is that you're gonna do. You're just committing to doing it every day.
Oh, okay.
During October.
Yeah, that's very good. I like the Star Road picture here.
Yeah.
But yeah, he's really cranking, like you're saying, doing one a day. I can't imagine. Like,
And there's usually somebody or somewhere around it will be doing some kind of theme for each day.
oh, okay.
But they're not really official. I think one of the days was like Shield, but it's just somebody, whoever posted first that day decided that's what there was.
Yeah.
And then they end up with 20 or 30 people following it, and then it kind of goes from there, and you end up with however many people.
Yeah. I noticed, like,
the word that he's using is the theme, or if that's just what he decided to do.
I'm not sure. Yeah, I don't know much about Inktober. So when you're doing Devtober, people aren't doing a game every day, right? They're just
No.
doing one
Well, I
game
think that I saw somebody I'm following is doing like a puzzle every day, but it's still just that the guy who's kind of spelled out what he was deciding to do with it was just that you work on a game every day during October, with the goal of having something releasable at the end of October.
Ah, gotcha.
So whether it was something new or just a project that you'd been kicking around for a while and hadn't like gotten the drive to do the last little bit, because we all know game dev is finishing is the worst part. That's
that last 20% there, trying to make time.
I think it's just the goal to actually finish something and release it, whether it's just on itch.io or you're going to put it out on Steam or Android, iOS, whatever you got, just that you're by the end of October, you're going to release it.
You got something out there. Yeah, just getting to that release point, I think that's a big deal. And I do like that, like working on something over a month instead of just like the 48 hours that I'm accustomed to, where you get a little bit more time to flesh out a lot of the details.
Yeah.
Yeah, I guess this is kind of like my Devtober. I developed this bartender game like back in 2015, but it was really bad. So I updated it and did a lot of the new models. Basically, you're a bartender and you got to make the drinks, and you got these different recipes that you have up here, and it gives you requirements. And you can have like different glasses, and once you make the drink, it tells you what you've made. You get to the next level. But yeah, I had a lot of fun working on this, making all the different little texture mapped bottles. Like you got your tequila and vodka, and you can make white Russians and martinis and things like that. Yeah, I don't know really what I'm going to do with this, but I would like to add like a simulation mode where like you manage a bar over time, and you got to you got to reorder your stock and things like that. Or you can just have it like puzzle mode where you just make the different drinks.
It almost looks like a study tool for bartenders.
Exactly. I've been watching like a lot of Bar Rescue, and they actually have methods that they use for pouring. I've tried to emulate that. Like for 1 ounce, you count 4 seconds. So I kind of matched that with this. If you hold down on your cup or your glass for 4 seconds, then it usually equals an ounce right there. So, yeah, I don't know if I could release this with all the brand names on the bottles. I'd probably have to come up with some fictitious names and things like that.
Yeah, change a letter here and there.
Yeah, exactly. Okay, so Joe, did you have any other projects you wanted to mention?
I'm on the SRPG game. I did want to say that for the first time, I'm dealing with a professional artist.
Oh, really?
That I've commissioned to make some art. And I haven't done that before with other games. I've thought about it, but this was like the first time I really reached out to someone and asked them to produce assets for one of my games. And we settled on some costs and stuff, and then so the first asset we're making, one of the characters, we've gone back and forth over the last couple of weeks about the style and the colors and different things with like the height and width and just how it's going to look and everything about it. So once we settle in and I figure out what I owe them for this first one, because we've gone through some reworks, then I've got like 8 or 9 more characters that I wanted them to make. So we're going to take them one at a time, but I'll probably try to talk about this experience, I guess, and just what kind of the steps were involved and, what my costs have been and how I picked them out of all the artists that are available. There's somebody I found on Twitter, and then I made a post on Reddit, and I went through a few of the people that responded.
Yeah, that would be very cool if you want to do a talk and like.
Yeah, I don't. So nothing's been finalized yet, so I didn't want to share anything yet.
Yeah, I was about to say, do you want to give them a plug? But then if it turns out, if it goes the wrong way, then we don't want to do that.
And I paid half up front, and then I'm paying the other half when we finish. Although I'll probably have to include a nice tip because of how much we've kind of gone back and forth. But they've helped me like kind of come up with the style by coming up with a couple of different designs and being, A or B, which one do you like better? And I'm colorblind, so like some of them I just had to show my wife and be like, like, are those brown or green? What's going on here?
It's good to like nail down the design of your characters up front, because you don't want him going off and like making a sprite sheet with like 20 different sprites.
Yeah.
Then it's like, oh, I don't like the color of his eyes or something mundane like that.
Or the hair or the armor. Yeah, I mean it's good. I like it where it's been going. It's actually been helping me stay motivated to like see the art that's being produced, I'm gonna be like, that's gonna be in my game because that's way better than anything I've ever made. That's and I've kind of come to terms with that I'm not an artist, and that's not gonna be where my skills develop. I've tried, but I'm pretty much gonna stick to the geometrics for jams.
Yeah. I'll definitely be interested. I'm always anxious to hear about success stories with artists because a lot of us here in Knoxville haven't had much success. I remember I worked with a couple of students one time, and it was kind of my fault. I didn't like set up like the parameters and everything. It was like, oh, who's doing what and who owns what. It's almost like if I'm working with a developer, it's like, okay, I got to pay you for this amount. But when I was working with graphics to go, it was like we're a team, and I'm really not exactly sure who owns what. And
yeah, and I've been in a couple different team situations before. And this time it's me, my double square, and it's just straight up from the beginning. I'm paying you to produce these list of deliverables, and that's it. That you don't have ownership of anything. We decided at the beginning that we could both share credit, like they can plug and use the art on their portfolio and say that they worked for this game once it comes out, and I can tell people that yes, this artist did the art for this game, or not just that I can, but I have to. Yeah, that they're credited for the art that they produced.
yeah, we had a good talk back when we were at the Tech Co. It was a musician that came in and talked to us, and he did go into some of the business details. I remember one of the things was the ownership was a point that you got to flesh out because he worked under like contracts where he would make music for your game and you could use it, but he could continue to sell the soundtrack on his website. And like after a year, he could like give that music for other people's games. I was like, well, no, if I'm paying you to make music for my game, I want to be the exclusive owner. I want to be the exclusive game to have that music.
Yeah, and I did mention that they would belong to the game in perpetuity. So like, if I do get really popular, I can't go like what's happened with The Witcher right now, where
I heard about that.
The writer is like trying to sue them for more money because it got more popular than he thought it would be, and they had agreed at the beginning. They just paid him whatever, $5,000 for The Witcher license. Yeah, and now that it is what it is, he's like, no, you should pay me millions, and they're like, too bad. Like you, you said it was fine. You didn't think it was gonna do good. So but it's also just for this game, so I can't use the character that they're making for me and like put it in 20 different games unless I pay them more for each license right that's specific to the game.
Yeah, I never thought about that. So if you like make a sequel, then they don't want you using the same artwork. They want you to come back and continue to use their services.
Yeah, which is fair. If it gets popular, then I'll deal with that down the road. But so far it's been pretty good. I mean, I really like what they've done so far, and we're going to try to get them to do everything. But I also don't have enough money laying around to just pay them up front for everything. Yeah. So it's going to be more of a like, let me get 2 characters this month, and then. But it's also developing the same time that I'm programming, so it's taking me time anyway.
It's like doing it in parallel, and it's like you're not having to like pile tasks like graphics tasks on top of game development tasks and things like that.
Yeah, I just hope that as I get further, I don't like change too much of my mind about stuff. Which is, I actually tried to write up a good game design document this time around in OneNote, which is I've been using that a lot more with the Microsoft OneNote.
Yeah, I haven't used it very much. I know it usually pops up when I'm doing different things. It's like, oh, send this to OneNote. Is it like a Trello type thing? Trello is where you can put different tasks on a board, a Kanban style thing.
Not really. It's more like just pages. like a fancier Word document, I guess, with the where you can have a table of contents on the side, and you can have different pages be different things like graphs or Excel charts. But it's got like tabs on the page, so you can have one for like the list of all the heroes, and another one can be a spreadsheet with all of their stats and stuff planned out, and then the next one can be a to-do list with checkboxes, and the next one can be just a bunch of art like lined up in a thing, but they're all organized in one page with tabs on it.
Yeah, that sounds very cool. Yeah.
And I'm
So you
like,
just bring all these different types of graphics and tables and things all together instead of like trying to shove them all in a Word document and pass the Word document around.
and it does sync in the cloud, so I can like get to it from my tablet or my laptop or my desktop, and it stays up to date from wherever I've put stuff in there, which is good. I have like one tab at the front that's just like ideas I have randomly, so sometimes I'll be out and about and have to open it on my phone and type something in there that I came up with, and then on the last two tabs I have like the story, and on one of them I have it like the outline that just that the heroes are going to this town for this reason, and then like on the next tab I actually have the script where I've been putting like writing it kind of like a screenplay where I'll say like hero enters from left screen and have the dialogue line from this person, and then I haven't started programming the script yet, like with the dialogue engine, but I'm trying to write in things that I think I would want, like different kind of Easter eggs. If the player has a certain character in their party at a certain moment, then they might have a line. So I know that I might plan for that later to do a check, or if I want to have an actual branching story where the player could make a decision that would change something.
Yeah.
Like a permadeath or if something else if you go to one town or the other or something like that.
Yeah, I'm thinking of like the old Final Fantasy games is like based on like how far you are in the quest line, but then there's like multiple quest lines, and one quest line can impact another one. Never really understood how they did all that, but I guess it's all just like linked list with like different checkpoints throughout.
Yeah, I've been messing around with there's a third party add-on in Game Maker it's like friendly cosmonauts dialogue thing where you can kind of like import a notepad document of your script, and like as long as you key them properly, that the dialogue message like 1Q01 or whatever, but it uses like 4 characters as the key for the order, then you can have Game Maker include the notepad document text file, and it will read from that to do the dialogue in the game.
Oh, that's very
so that
cool.
way I can update the text document instead of having to like program it in or program changes in whenever I want. And then I could also take that same text document and go on Reddit or wherever and ask for fan translations, because people do that.
Yeah, that's what I was thinking of. I was like, oh, yeah, just it's easier to give a translator just a text file to update than have to go into the actual game code. That's kind of like what I'm doing with that bartender game. So I have like different text files, or actually in JSON, which I don't know. I'm starting to like JSON more and more, even though there's a lot of redundant information, but it makes it really easy to edit because it's all text. But I have like one JSON file with all the drink components, the drink types, and I have one just for the recipes. So it'll take the drink components and say how much of each you need. And then I'll have one for like quest. It's like, oh, make these 2 drinks or these 3 drinks, and I just pull that in. It makes it really easy to manage all that data. But one thing is you got to make sure, like you're talking about with your keys, is like I got to make sure the spelling is correct. Whereas if I was using like some database system or something, I would just have like some surrogate integer or something that would represent that string value.
Yeah, the keys are like the first 2 or the scene numbers. So like 2A, 1B, 1C or whatever is where it's happening. and then the other numbers are the order. So you start with like 00, 01, 02, 03, and count up. I'm not sure how it handles if you go over 100. I haven't looked into that yet.
Yeah.
Although most of the ones I've written only have like 7,
Yeah.
maybe 10, like that. So I don't know if I need to worry about 100. That'd be a lot of dialogue in one.
Yeah, you never know.
Cutscene.
Once your RPG gets so big,
Yeah.
you'll need all that extra space you can get. Yeah.
And then still working into it, like the cutscene, other control. I have like a controller object I've been writing scripts for if I want like the camera to pan left to right over the scene, or like having the different hero characters come out in view and move around and have like emote bubbles above their head, like an exclamation point or something, in time with the text that's happening, with the player being able to like press A to continue, kind of thing. Didn't have any plans to do voice acting, but I thought about it. I voice act everything myself would be funny.
Yeah, that would be cool.
Do all the different characters.
I know all those old school RPGs. I mean, they're heavily influenced with dialogue and the cutscenes and just telling the story. And I've never really like got into that, so I'll be interested in hearing your experiences with how that turns out. But that sounds like a really good plugin. So it's just like a plugin for Game Maker.
Yeah, it's free.
It's free.
Like,
okay.
They just had the maker of it on the official Game Maker podcast.
Oh, okay.
Which was called like, well, no, I don't remember. But
I guess you can just go to iTunes and type Game Maker or something.
Yeah, and that's just something that they made.
They just shared it out for everyone. That's pretty cool. So is there like a repository for Game Maker plugins, or you just gotta like go to this guy's website?
I mean, I just go to the Yo-Yo Games website.
Yo-Yo Games, yeah.
They have them there. They're not really greatly organized. You can, like, all the script plugins are just in one thing with 500 results. But if you sort them by like most downloads or popular views or whatever, they naturally the good ones have floated to the top. There's not a ton to have to filter through, but there are some interesting options there.
Very cool. Yeah, I'll definitely probably check that out if I do GM48 next weekend. See what type of plugins there are that I can. Because I think in GM48 it's kind of like Ludum Dare. You can use anything out there that's already publicly available, I think. Mm-hmm. Very cool. Well, I'm going to go ahead and start share out my presentation slides. Yeah, I was going to talk about AI this month, artificial intelligence. And I think AI can mean different things to different people. I know there's just going out to YouTube and searching for AI. You find a lot of stuff as I go about Terminator and what people have watched in the movies and Matrix, and it's like, no, that's really not AI. I mean, I guess it could be, but I wanted to get into it a little bit more. When I was in college, my undergrad degree, I did take some theory classes. Nothing specifically in AI, but a lot of these topics out there, they're kind of separated, disjointed from game development. Like you can hear people talk about game trees and stuff, but they never do explain really how you use those in games. So that's what I was kind of hoping to go over and talk about with this presentation. So some of the topics I'm going to go over, decisions, like Joe, you were talking about earlier, how to make decisions and evaluating alternatives, just at a very high level view. The point of this is to like introduce these concepts, and if people are interested, then they can go in and research these a little bit more, because I'm sure on any of these topics, like someone could spend hours explaining any of these. Yeah. But so tree structures, computation time, conditioning, and expert systems. So I started out with just like Tic Tac Toe, trying to like calculate the best way, best artificial intelligence to play Tic Tac Toe. Some other people have looked into this as well. But once you start calculating the outcomes, you find out there's so many just like different ways that the game can go. So if you can imagine just like a 4x4 Tic Tac Toe game, that results in 16 different outcomes. So you calculate that, it's 2 to the 4th, which is 16, because you have two alternatives. You can either have an X or an O, and so that's 2. Then the number of spaces you fill, that's the power that you raise it to. So 2 to the 4th is 16. So the number of results in a tic-tac-toe game will be 2 to the 9th, which is 512. But even with that number of outcomes, there's even more ways to actually get to those outcomes. Like you may start out with an X in the top first, or you may start out with the X in the bottom right corner, but you could still end up with the same result. So I didn't calculate this, but there's actually over 255,000 ways to go about filling in a tic-tac-toe game. And yeah, there's 252 valid outcomes if you're actually alternating turns between players, because in the previous example, that's just saying with the 2 to the 9th, that's letting you put any number of X's in any number of O's. So if you actually filter out the invalid outcomes where you aren't alternating terms, and it comes out to be 252. So this gets into the concept of combinatorics, how many different ways you can rearrange the letters or different items in a set. And one of the classic examples, like I remember hearing this one in high school and even throughout college, is one of the first ones you'll probably learn in Algebra 2, or if you take a college combinatorics class, is how many ways to rearrange the letters in the word Mississippi. Now, if you just have the letters themselves, there's 11 different letters in Mississippi. If you have a 11-letter word with all different letters, then it's 11 factorial. So, and it's represented by 11, then an exclamation point. So that basically means 11 times 10 times 9 times 8 times 7 times 6, all the way down to 1. So that's the number of ways to rearrange a set. If each of the items in the set is unique. But in the word Mississippi, well, we have 4 S's, 4 I's, and 2 P's. So what you got to do is take that 11 factorial and divide it by each of the letters that appear multiple times. The factorial of each letter that appears multiple times. So you divide that by 4 factorial times 4 factorial times 2 factorial. So you get 34,650. So yeah, once I started looking at this tic-tac-toe problem, one method that I found for assigning decision values for each of the squares, like which square do I want to pick in this 9x9 grid? Well, you can give each of the cells a weight based on how many ways I can win with that cell. So the center square, I can win 4 different ways. I can either go across the middle, up and down the center, or diagonally both ways. So naturally, you would think that would be the optimal choice in a blank tic-tac-toe board. You can also pick one of the upper corners, one of the corners. That gives you 3 different ways to win, either straight across the top, straight across the side, or a diagonal down the middle. And you also want to be able to calculate the number of ways you can lose. So here's one like decision point in a tic-tac-toe game, just a random tic-tac-toe game. I recommend anyone that's actually listening to this through the podcast, check out the YouTube version of this, which I'll post soon, so you can actually see these graphs. I'll also be posting these presentation slides on the Knoxville Game Design Org website. Knox Game Design Org website. So we've got 3 O's and 2 X's, and we want to determine which spot we want to put the next X. So there's 4 different possibilities right here. And one method that I was reading about was, well, check each square for the next possible turn. and then calculate how many ways you can win with that square. So you can see in this first one, you got 2 different ways you can win, either straight down the center here or on the left side and down the center. And the same for all these other cases. You can win on the side or the center. But in this case right here, the other player, O, he has 3 ways to win. So you're basically taking the number of ways X can win, and assuming that you are player X, or the AI is player X, and subtracting off the number of ways that player O can win. So you'd want to pick one of the first, third, or fourth, because that reduces the number of ways that O can win. But one thing this doesn't take into account, one thing about this method, is that if you don't pick this first value with the X in the upper left-hand corner, then O gets an automatic win, because they can just pick this one right here and automatically win. So really you want to select this option on the left side right here to block the O. So that gets into the case where you want to give O, the probability of O winning, like an infinity value. So you would have this px minus po actually equal infinity. So you'd want to pick that one right there. Or negative infinity.
Or check wherever 2 O's already exist in a row or something would way higher than
exactly
just your own winning. Yeah.
Yeah, because you got to look at your
next round is more important than the whole game.
Exactly. So you got to look out for both the number of ways that you can win, then also the number of ways that the opponent can win. But there's like some like nuclear option states where it's like, okay, if I don't pick this one right here, it's like Hollywood Squares. It's like, oh, I don't pick this one for the block, then I'm going to lose.
You'd probably do something like that, like for chess, it'd be like a check.
Exactly.
So that's more important than where your piece is going, because you have to prevent their victory right now.
Exactly.
Before you can go on to the next decision.
So in that case, it's like your king is in check. So moving your king is like you would weight that as infinity compared to all the other. It's like, oh yeah, I'm not worried. I might give like moving my pawn up 1 square value of 1 or something, but you want to.
Well, you'd have to still include the idea that your own check could check for current victory would be even more important.
Exactly.
Because then if you could win right now, it doesn't matter that they might win next turn.
Exactly. So the other thing I was going to mention about this is these game trees can get very huge. It's kind of like exponential complexity rate growth, because so for each, this is just one state and you got 4 different moves. So for every one of these states, then you also have like 4 other states. After you put your X here, then you're going to have 3 others like coming down from here. Then from each of those, you're going to have 2 more coming down from there. And I think it is possible to brute force this with Tic Tac Toe. But my next slide you're talking about, Joe, is chess.
Yeah.
So this is exactly what you were talking about. I found online there's like different ways of ranking pieces, but typically it's like your pawn is worth a 1. Your knight, bishop, and rook, they're either worth like 3 or 5. Some people give them fractions, and your queen is worth a 9 or a 10. And this is kind of like what you're talking about here, Joe. I said, okay, in this case, your queen captures a bishop. That may be like the highest piece that you can capture. But if you capture that bishop, and then on the next turn, the knight captures your queen, then you're at a net negative.
Yeah, one of the computer programming classes I took back 2009 was chess was pretty much all we talked about. That was everything came back to how it works in chess, and that's it works as a good standard because it's a game that's been around a long time and everybody has figured out what these values are.
Yeah,
but that's when you're programming your own game, that's you kind of have to decide for yourself what
exactly
is valuable.
So like in your RPG, you may have like health for a character that would be like a value, or the strength of your character is like, oh, I got these scrubs on my team, but I got my if my healer goes down, then it's game over for me. So it's like the healer may be the number. I remember playing World of Warcraft. If your healer goes down, then you're dead pretty much. So yeah, there's like no like picking these values is kind of arbitrary, but I guess you can come up with different ways of selecting those. So I was talking about these tree structures, and so say you have a tree, and as I was talking about earlier, you have to look multiple moves ahead, and to be able to look multiple moves ahead, then each one of those decision points is a branch. And basically these tree structures are composed of like, in C, they would be like a structure with a couple of pointers, 2 or more pointers. A pointer is just basically an integer value that holds the location in memory toward the next structure. So you get these recursive relationships. But you can build like I think they call them like in-array trees, where you can have a node with multiple. But one of the common ones people use is a binary search tree. What's unique about this one is that with each node, the node to the left is always less, and the node to the right is always more. So you may have to do some preparations in your decision tree to get it this way. There are algorithms out there for inserting into binary search trees to make sure they're balanced. So this is just one that I came up with right here. There's multiple ways to traverse one of these binary search trees. This is like one of the first things that I learned in my first computing class in college. Many people have probably seen this as well, but you have 3 different methods. You can either go pre-order, in-order, or post-order. And the way to actually calculate these by hand is like drawing a bubble around your tree right here. And in the pre-order, you want to take each node and make like a little line to the left of it. And then you just start at the top and go around, and every time you hit a line, you just write down that number. And that will give you the pre-order. And you go counterclockwise. For in order, you go around and just draw a little line below and go around counterclockwise, and that will give you the in order. So in this case, it's 9, 14, 16, 20, 32, 40, 57, and 99. And that if you go in order, that will give you an ordered list. In post order, you do the same thing. Just draw your lines to the right side and then go around, and that will give you the post order. Typically, I use in order for most things, but I think there are cases when you can use either or post order too if you're not concerned about the data coming out in order there.
Yeah, I've typically learned to do in order as well. I think it just helps mentally grasp what is happening.
Yeah, exactly.
Especially for troubleshooting afterward.
Yeah.
When things are failing like halfway through your plan.
Yeah. It's always nice to... I don't know if the runtime is any slower doing in order, because basically you just have a function and you say if you're doing in order, then it's like, okay, you call this function again, and then you pass the left node, and then you just call that function again until you get to the leaf. The leaf node is like, oh, there's no other branches going any other way. So usually those are like null pointers right there. So if you get to a null, then you pop back up in your recursion, then you start going down the other way. So yeah, I'm just introducing these concepts. If anybody out there is like thinking about getting into computer science, especially like at the college level, then this is like an introduction of some of the stuff you'll be learning.
Yeah.
So this is one that I don't remember hearing much about, but it's apparently used pretty frequently in game trees. It's called Minimax. So basically it's a tree, and the ones that I found just had values at the leaf nodes here at the bottom. And here I have 16 different leaf nodes. And it's almost like min is your opponent and you are max. And you want to maximize your value. Might be like coins or gold pieces or health or something like that. But the opponent wants to minimize. I guess you can think of it like playing cards or something. The opponent wants to minimize your score, and you want to maximize your score. So in this case, we look at the tree nodes like doing an in-order traversal. You go all the way down, look at the 3 and look at the 1. So for this level, we want to get the minimum. So for the minimum of 3 and 1 is a 1. Then we pop back up and go back down. A minimum of 4 and 1 is 1. So we do that for each of these terminal nodes here. And so we get a 5 and a 2 between 2 and 6, 3 and a 5 and 3. So we get all the min terms right here. Then once we're finished with that, then we pop back up to this next level of branches. And we want to get the maximum for those. So you can see for each level we have either min or max. So the maximum of 1 and 1 is 1. The maximum of 5 and 2 is 5, and we keep on going, get a 5 and a 7 there. Then for the next level, we look at min again. So the minimum of 1 and 5 is 1, and then the minimum of 5 and 7 is 5. And then we have, that's our 2 final nodes right here, so the maximum of 5 and 1 is 5. So the mini-max traversal will be going from the top to the right, to the left, to the right, to the left. I'm not sure exactly how you could use this in a practical game.
I think I've seen the tree before. It's been a good few years since I was in school for this, but I think the example they used with this was that it gets rid of the outliers, like in a first-person shooter, if they were using a decision tree.
Oh.
Like that the enemy, if they're trying to decide what they're going to do with the AI, whether it's like run for a power-up or shoot at the player or jump somewhere, like it gets rid of all the stuff where like they're not going to duck. So if we know they're not going to duck, that's not something they're going to do here, then there's no reason to calculate everything else they might do after ducking. So they're either for sure going to start down this path and then work their way through the potentials of that path and it's supposed to cut down on like the computational load a lot when you have a lot running. But it's like it's that's what I'm saying. It's probably been 7 or 8 years since I saw that kind of graph.
I think that's a great explanation. I mean, it just kind of gets rid of the outliers. It kind of balances the minimum cases and maximum cases together.
Yeah, especially when you have like a real complicated game, like a first-person shooter or a Dota, where you have a really complex AI. You gotta decide what they're gonna do.
Yeah,
and that's
There's actually videos out there. There's another method that you can use with these mini-max trees. So this was like a full traversal of the tree, which is bad. A computer, like I was saying earlier, is like, once you get into thousands of branches, and it becomes uncomputable. It just takes too long, especially when you're doing this every 1.6 hundredths of a second, every frame, 60 frames a second. So there's another method it's basically mini-max, but there's alpha and beta pruning. So you keep an alpha and beta value. And I recommend, there's some videos from MIT. I think it's called MIT OpenCourseware. It's on YouTube. Just look up Minimax MIT, and they can explain this a lot better than me. If I mean, I could probably do it if I had to, but trying to explain it in real time is kind of difficult. But basically, you have an alpha and beta value. I think the beta starts at like negative infinity and alpha starts at positive infinity. And keeping track of those values as you do this traversal, Joe, like you're saying, you can like short circuit some of these traversals. It's like, okay, I've already looked at these, and this branch won't ever be like less than these other ones. So I don't even need to traverse through these. And just pruning that much of the tree can make it run a lot more efficiently than traversing the entire tree like I've done here. I was also going to mention red and black trees. Those are also binary search trees, as I mentioned earlier, but there's an extra bit The problem with binary search trees, if you're inserting values into them, and say like on your root node you have like 99, and then all your other nodes are like 1, 2, 3, 4, it never gets above 10, well, you're going to have a lopsided tree, and you're always going to be going down one long path. So these red-black trees, they have an extra bit. It's called like either the redness or the blackness, and it's a way to make it so whenever you insert a node into a tree, then it keeps it balanced. It's more looking like this, where you got an even number spread across. And I recommend, like, Wikipedia actually has a pretty good explanation of how to actually insert into a red-black tree. So as we were talking about complexity, looking at these problems, trees, traversals, there's many different ways to calculate complexity. One that's commonly used is called this big O notation. So this is used a lot in computer science and in computer theory to determine if a problem is solvable within a reasonable amount of time. So big O of 1 is just constant time. That's saying, okay, I got an array. I know exactly where the data is I want to know exactly what's in cell 42. That's big O of 1, or constant time. Very efficient.
Yeah.
Big O of log n, logarithmic time, it's like that binary search that I was talking about. It's like, well, you got all these values, but they're in some sort of order where I can traverse this tree and find the value that I want. So I don't have to go to every node if I know the tree is balanced. So that's logarithmic time. Big O of n, that's linear time. So that's like you have to if you have a list or an array, you have to visit every single item in the list. So you got to visit everything. Or, for example, if you're trying to get a sum of all the values in a list, then you got to visit every single node or an array. You got to go through every index in the array to sum those values up. So that's it takes a little bit more computation time than the log n or the constant time. Another one is called big O of n log n. I can't tell you all the specifics of this, but it's like when you're sorting, which may be in like a higher level of time, like polynomial time, this does it a little bit quicker than that. And then, as I mentioned, there's polynomial time, which is big O of n squared. So these polynomial time, we try to get all computing problems for games and other things, at least in polynomial time. So these are problems that can be solved by a computer in a reasonable amount of time. But then you get into these problems that are big O of 2n, 2 to the n, which is exponential time. And these are the problems like we were talking about earlier, chess, even Tic Tac Toe, if you extrapolate that out into larger values. These are not problems that can be currently solved by a computer in a reasonable amount of time. It could take years. Like we said earlier, the pruning helps to reduce this, but exponential time, you want to stay away from that. So there's this whole concept of called P versus NP. P problems, like I mentioned, these are problems that can be solved in polynomial time, the 2 to the n. Now, n squared. So n squared is a special case of polynomial time. It's quadratic time, but any constant value, 3 to the n or anything like that, is polynomial time. Let me see here. Yeah. N to the squared is quadratic time. N to the cube is polynomial time, or n to anything is polynomial time. 2 to the n is exponential time. I get those mixed up. So NP problems are problems that this basically stands for non-deterministic polynomial time. And most of these, you can verify the answer. I know a lot of people reference Sudoku. You can actually confirm that an answer is correct, the final state that it's correct in polynomial time. But to generate that answer is going to take exponential time, which is not solvable by a computer in a reasonable amount of time. Then there's these class of problems called NP hard, and these are the hardest problems in NP, non-deterministic polynomial. These are problems where it may be where the finding the solution isn't possible by a computer, and also verifying even the solution is impossible. And one of the problems, NP complete, not sure if this is NP hard or not, but the traveling salesman, this is a common example, is like you have different nodes that are connected, and this is actually a graph, like for different cities, and the different distance between each cities is the edges between the nodes in the graph, and to find the minimal spanning tree between all those cities. I don't have a picture of that right here, but that's an NP hard. It's not calculatable by a computer in a reasonable amount of time. Now there's a specialized case of this traveling salesman. I consider it a specialized case, which can be solved with Dijkstra's algorithm. And I think I heard about Dijkstra's algorithm in half my computing classes. So this is a good one to learn right here. If anyone out there really wants to get into computer science. The specialized case, it is like traveling salesman, but you have a start and end node. And I'm not going to go into the algorithm here, but basically you have to find the shortest path to get from that starting node to the ending node. So just constraining it to two different like cities and finding the path, that makes it computable in polynomial time, quadratic time. This is called the best first search. Yeah, so you visit all nodes. So that can be useful in a game. Here's a real example from one of my games. I don't have a decision tree made for this, but my Easter egg hunt game, you have so you got to define all the values. So you have 3 different possibilities for your character. You can either go for an egg gives you points, or you could go, and there can be bonus eggs, which are worth more points, or you can go for one of the 2 power-ups. One is a carrot, and one is this little star snowflake thing, and that freezes all your enemies. So you have 4 different decisions here. You can either move in a straight line toward the closest egg, you move in a straight line toward the bonus egg, or you can go to either one of the 2 of the power-ups. The factors you got to weigh into this is what's the current score. If I'm really far behind, I may need to go to the bonus egg. If everybody's way ahead of me, then I may want to get the snowflake power up to freeze everybody. And I'm basically looking what outcome gives me the ability to guarantee a win for myself. There's even different ways you can calculate wins. Like in this game, you can tie. Is tying a valid outcome? Because if you put money on whether I'm going to win the game, then I definitely want to win. Or you can just put money on me not losing. So then in that case, a tie may be acceptable. But to guarantee a win in this case, your score has to be greater than the total number of points for all the eggs divided by 2. Then after that, you don't care. It's like you can just like sit there and do nothing. Yeah. So I also wanted to mention about conditioning. This is another way you can like give your AI a little bit of an advantage. All people are basically animals, and we can be conditioned. Some of the early experiments were the Skinner box, where you have this mouse, and he just wanders around in this cage, and randomly he'll hit this little lever, and then a piece of food will pop out. So he likes the food. That's good. And then he'll continually wander around, and he'll hit the button again. Then there may have been a light in here too, like hit the lever under the light, and then food will come out again. So the rat eventually learns that, hey, if I press this button, then the food will come out, and that's a good thing. So he becomes conditioned to doing that. There's also Pavlov's dog. I believe with Pavlov, he rang a bell and then gave a dog a piece of food, similar. Then after a while, he could just ring the bell, then the dog will start salivating, ready to eat for the food. The way I kind of explain this is in rock, paper, scissors. If you have the CPU and they continually pick rock, The player may start out like picking scissors or rock, and it's like, okay, I picked scissors, I lost. That's a bad result. I picked rock on his rock, then okay, we tied. But eventually the player will realize, hey, if I start picking paper, then I'm going to beat the CPU's rock. That's when the CPU can go in and pick scissors and beat the player because he's conditioned to pick paper. This is applied in fighting games, at high levels of fighting games. Basically, in most fighting games, popular ones, you have where I got all the different conditions listed out here. Low attack beats a standing guard, throw beats a standing guard, and crouch avoids a high attack. In some games like Tekken, you have a mid attack that can beat a crouching guard, and a parry beats a low attack. In Street Fighter, you have an air attack can beat a crouching guard. So the point of all this is I've seen a lot of fighting game tournaments where one player will continually low attack the other player to condition the opponent into doing a crouching guard. So once the player is conditioned to do the crouching guard, then they can hit him with a mid attack for a big, meaty chunk of damage right there. So when you're designing AI, you can take this into consideration. So another part of AI, and AI can mean multiple things, but it's this concept of an expert system, building a knowledge base. So one of the first AI languages that I learned was Prolog. I think this was developed in the 70s. The guy's name is, I'm probably mispronouncing this, but Elian Colmeirer. Probably French or something. I'm sure I'm butchering his name. But it's based on this concept of an inference engine. Two concepts together infers another piece of information. All these inferences together builds a knowledge base. So I actually have a Prolog interpreter that you can download for free. It's called SWI Prolog. I like this one a lot. But basically, I created a knowledge base, and I'll load it in here. You call it consulting. And this is JoJo's Bizarre Adventure. So if anybody out there hasn't seen JoJo's Bizarre Adventure, you may be confused in this. But you can read up on that if you want to. But here's my JoJo's Bizarre Adventure knowledge base. So I got the different stands, like each character has like this familiar type character that's like a summon that fights beside them. So I defined all of these, like here's Star Platinum and Hermit Purple and Magician's Red. These are all defined as stands right here. Then you can make a relationship between the stand and its owner. So I got this relationship called owner. So it relates each stand to its owner, like Jotaro's Star Platinum and Joseph's Hermit Purple. Then you can start, and this is like the classic example of Prolog, is building these relationships between family members. So you can define the mothers and fathers and husbands and wives. But the real power is when you start building like these inferred relationships. So a grandfather X of Z is inferred by the father of X to Y and then the mother of Y to Z, or the father of X to Y and the father of Y to Z. So you build that inferred relationship without actually having to define it in your knowledge base. So basically your standard Prolog query, you can do stand and say Star Platinum. End it with a period, and it's going to say true. Now, if you're going to stand, you can do stand of, say, Heart Platinum, then it's going to return false. It's not a stand. Then you can do stand of capital X. And X's are your variables. All of your tokens here have to be lowercase. So if you do stand in a variable, then it'll just basically return all of the stands that are defined in the knowledge base. You can also do stand Jotaro X. Owner Jotaro of X. And that will return star platinum as well. You can also do owner Y and X, and you just press semicolon. That will return all the relationships defined in the knowledge base. You can do father of Jotaro, and I think I'm doing this one backwards. X of Jotaro. So he doesn't have a father defined in the system. But you can do the other way around. Nope. Let's do SEPX. So Holly's father is Joseph. Then you can do the grandfather relationship. Grandfather X to Y. And this will return all the grandfather relationships or the uncle. So uncle is a special case because your uncle is your your grandfather's son or daughter. But you got to do these not cases because you don't want to return your own mother or your own father. This could be like defined, I guess, with brothers and sisters as well. So the way, and I actually spent some time, let me open up Unity here. I actually got Prolog working in Unity, which I'm going to bring up any moment now, depending on how long Unity takes to run. Oh, I'm waiting on that. I was going to mention we were talking about runtimes earlier. This cool program called Sound of Sorting. I found a video of this on YouTube, but this may be loud. You can run this and it will actually show some of these various sorting algorithms. So if we're talking about computation time, you can actually see some of these sorting algorithms running like this, and it has really cool sound. I don't want to like blow people's ears out, but you can hear that. You can like actually go and like pick a bubble sort and run that. You can see how each of these sorting methods work right there. So here's my Prolog test in Unity. So I have an explanation of how I got this running. There's the SWI Prolog right there. But I tried a couple of the different packages from NuGet, N-U-G-E-T, and Visual Studio. Unity really doesn't like it when you use NuGet packages. Basically what you got to do is install that package, then drag the DLLs into your Unity project. Otherwise, Unity will complain and it won't like it. But a couple of them were like really old from 2011 or 2012. They didn't want to work. I found one that was updated in 2018. It worked pretty good. The one that I'm using here. So I basically got my knowledge base. This PL file is a text file. Pulled it into the resources folder in my Unity project and assigned this to a text asset into this Prolog manager script that I created. So when I run this, I can do one of my queries like stand X and run that. Then it returns star platinum. So you can either get the first solution or get all solutions. It works a couple of different ways. But I can do owner, I think Joseph X. Run that, then it'll return Hermit Purple. And so, yeah, here's the knowledge base right here, all the different relationships. So I guess the whole thing about expert systems, and I've worked with a couple of these before. I'm not sure if I made a note about it here or not, but it basically requires a knowledge matter expert to load in all these rules into the system. So if you put garbage into a knowledge system, then you'll get garbage out. Yeah, that's where I have it. Results are only as good as the input information. And it's really important because a lot of times knowledge experts aren't computer savvy, so you got to make tools for them to be able to enter their knowledge into the system. There's other functional languages that kind of work like Prolog. Lisp or Scheme, they're both functional language. I think there's like an F# too, Microsoft one. And what this is trying to do is create a neural network, basically emulating the human brain. And there's lots of videos on YouTube. And just type in neural network if you want to learn how brains work and how they send signals between the different nodes in the brain. Other considerations, like I mentioned earlier, you only have 100th of a second to do a calculation. You may want to do some of these decisions in the background. I'm not sure if you could actually, if you could like fork off a thread, like if you have some AI, if you have a character and he needs to make a decision, just fork off a thread and do some of these calculations. In puzzle games, this is less of a factor just because you have a lot more time between moves. If you're doing a puzzle game, it might be good to like give the player like something that says the CPU is thinking or computing. And yeah, consider your big O running time. But sometimes you don't really need complex AI. I really liked a lot of the old NES games, like Mega Man, Punch-Out. Like in Mega Man, you fight the robot bosses. They always move in the same pattern, or there's just a little bit of a deviation, but it's really not doing any like heavy calculations there on determining the outcome. So sometimes maybe AI isn't the best route to go into. But it does make the enemies more predictable, and I guess it all comes down to whether you find that fun or not, learning the patterns. Here's an example for determining an AI choice. This is like an RPG, that, like when I'm doing a Ludum Dare game, this is usually what I do right here. And this isn't looking at trees or anything. This is like the simple NES AI. So let's just say I want to attack 50% of the time, defend 30% of the time, or use a special power 20% of the time. Just create these distributions, and you pick a random value from 1 to 10, or 0 to 100. And if your value is less than that distribution value, like for attack, then you do attack. But if you want to check for defend, then you want to check if that random value is between the attack distribution and the defend distribution. And then if it's not in there, then you want to check between the sum of the attack distribution, defend distribution, and special distribution, all the way up to 100 or 10 or whatever your maximum value is. So that's like the simplistic AI. It's like the enemy is going to do something based on a percentage value. But the problem with this is that, like I put here, it can be streaky. You could have like an enemy, even though you have your special power at 20%, an enemy could do 5 special attacks in a row, just if the random number generator comes up that way. And random number generator is basically based on seeding your random number generator with a value, such as time. So one thing that I've done in some games is you can seed that random number generator. I'm sure this is the same for Unity, and I think Unity kind of hides this in the background, but I think you can still set a seed. I'm sure it's the same way with the Game Maker or SDL and everything else. But typically you seed that with the current time, because finding the current time to the millisecond is pretty hard. So that's usually a good way to seed your random number generator. Here's a little bit better method for selecting AI choices. So I got my 3 attack, defend, and special attack, and you can build a list and just load in these different choices into a list based on that distribution. So you can like load in like 5 attacks and 3 defends and 2 special attacks, and you can insert these at random locations based on the current list of the string. So then you can just keep pulling these different choices off the list. And then once the list has no values left, you just build the list again. And you keep pulling those off. So this is kind of good for a puzzle game. I kind of do this for like Tetris. I put all the pieces into a list. Then I just pull those pieces off one at a time. Once that queue is out, once the list is empty, then I generate that list again. And okay, so this may be the best solution of all here. So basically you can have 3 different values based on your distribution, 5 attack. These are just integers. And every time you need to do a choice, just basically pick a random value. Yeah. And then you just subtract off. You pick a random value in that range of the sum of all of these. And then based on which number you pick, you do that action. Then you subtract 1 off that value. So it's like if it picks defend, then we're going to subtract 1 from the I defend distribution. Then once all these get to 0, then we're just going to reinitialize these to their initial value. So this is probably much more efficient than creating a list, and it's not less streaky than just picking a random number from a distribution. Yeah, a couple other things I wanted to mention. Other strategies, you probably hear a lot about rubber band AI. Kind of makes the game a little bit more fun. If your character gets way ahead, then it kind of helps the characters far behind. If you're falling behind, then it slows down the people ahead. There's like tons and tons of videos about Mario Kart and the blue shell. So if you want to learn about rubber band AI, you can watch one of those videos. Strength in numbers is, Joe, what you're kind of talking about earlier with RTSs. So yeah, one common strategy in StarCraft is the Zerg Rush. So you just create your lowest level units, just run those up, and you run them in one time, and you get a quick win. But if you basically took your starting location and you put a flag on the enemy's base, and you feed one Zergling in at a time, then your opponent's just going to pick those off one at a time, and you won't ever defeat your opponent. So there is a case to be made in strengths and numbers. Or if you're playing like a beat 'em up game like Final Fight, it's better to have your enemies surround the player than having one wait and come in one at a time. Yeah, humans are limited to input devices, so you can basically have your AI basically do whatever you want. And the AI can actually alter the game itself. You can have the concept of overpowered bosses, which I talked about in the human-computer interaction talk earlier. So yeah, I guess that's it. I thought I had some other demonstration, but maybe not. Let's see here. Check the notes. And here, prologue. What's this? What could possibly go wrong? Let me pull this up right here. Reinventing. Oh, this is the issues with NuGet right there. But yeah, that's basically what I had on AI. My really quick overview of a bunch of small topics there. So I guess that's all I had for this month. Let me bring back this and stop sharing. Joe, did you have anything else you wanted to show off this month?
No, not right now.
Okay.
That's it. Like developing my movement engine was all about like getting it from exponential. Like I know I can just go through a map and look at every tile in the map and say, can I move here? And go work my way backwards, but that was a horribly inefficient way to do it. So get it to like backtrack a decision from an exponential equation down to a linear or even just the polynomial, yeah, to make it run faster. Like yeah. I know I only need to check the tiles around the player if he can move there. There's no reason to check the whole map.
Yeah, it sounds almost like a traveling salesman problem. But you know your starting point, so it could be like a Dijkstra's algorithm problem. I guess Dijkstra is more of pathfinding. It's like, okay, I'm at this position and I want to get to this other position. And what's the most efficient way to get there?
Yeah, I think it's something current game designers, us included, now working with the computers that we have, probably don't have to give as much thought to, like the NES programmers back in the day that had to worry about like making stuff run when they only had, an x86 running it. Like he could.
Yeah,
it needs to only have 5 possible choices, because if you give it more than 5, it's going to explode.
Yeah.
And we're like, it's wasting about 1 million logarithmic decisions there, but it works, so it's fine.
Oh, I know what I was going to mention earlier when I was talking about the different run times or the computational complexity. So with the whole n equals np, if you can solve that problem, there's like all these problems out there, and I forget exactly who started this or what the organization is, but they're called the Millennium Prize problems, and there's like 8 of them or so, and I'll put a link to it in the show notes. But if you can solve any of those problems, and you can like win $1 million, and P equals NP is one of the problems. So if you can determine that all NP, non-deterministic polynomial time problems, are solvable, like Sudoku with the computer, then you win the $1 million. And it's like you break all computing as we know it. Because all of our encryption algorithms are based on factoring a number into its 2 primes. And that's another NP hard problem. So if you can find out a way to do that, then and what they say is if you can do it for one NP problem, then all NP problems become P. All non-deterministic polynomial time problems become solvable in polynomial time. And what I've been hearing about on the internet is with quantum computing, and I'm not an expert to talk on this, but I think it's based on, it's kind of like the wave-particle duality of subatomic particles, kind of like in Schrodinger's cat, where a cat can be alive and dead until you look at it. Like a bit can actually be a 1 and 0 until you measure it. Something in there can make these problems. What they're saying is like something with these quantum machines can solve these problems in a reasonable amount of time. Currently, and they're called qubits. So currently, the biggest processor they have has like 49 qubits, but they actually have, and I forgot. I think I was going to share this out. If you want to play with a quantum computer, they actually have them online. You can actually access it through a web browser. I'll bring that up right here. If I can find it. Quantum experience. .ng.bluemix.net. And do I got to sign in here? Sign in. And basically, you can play with these qubits and make different. And I really haven't got into this myself, but it sounds pretty cool. I gotta log in here. Open my vault. Okay, so I can't log in, but yeah, I recommend checking this site out if you want to learn more about quantum computing. And maybe there's one of the quantum computers right there. But they do give you an online interface for interfacing with one of these quantum computers. And they have a lot of different videos about quantum computing if you're interested in that. So anyway, sorry about cutting you off, Joe. I went on a tangent there.
Well, I mean, it's the same sort of idea there. I think with game design, it's all about first finding a solution that works programmatically, and then paring it down to making it work fast.
Yeah.
That's because that's just like when we were programming on calculators or even, the older computers, you couldn't just go with the thing that works because it would take 30 minutes to figure out if it works. And as computers get better, the current programming people learning programming right now are able to ignore the same sort of rules, exclusionary rules that we had to come up with to make things work.
Yeah, it's like nobody programs in assembly, or not a lot of people program in assembly more. So I can imagine, like the people from 20 years from now, it's like, oh, you actually wrote programs. We just do our neural networks and it works or something. But,
Yeah.
But yeah, your problem sounds a lot like the painting problem. Like if you have a grid or an array of pixels. I don't know if you remember the old paint programs, but you would basically click on a pixel and it would flood fill that. So you basically just go like all the way up and then all the way left, right, and but you have to like create a second array to make sure you're not revisiting one of the one of the points.
I had to do that. Yeah. Or in my case, I mean, I gave the individual tiles a state, so they were able to flip like if they were checked or not the first time around. But you still want to check from each tile because you need to do a potential for every possible move pattern because it matters, especially if there's obstacles. Whether the player goes right then up or up then right could be different. So you can't just say, yes, I've checked, up and right. I need to check up and then check right, but save time by not checking the same ones. Yeah.
Well, the good thing is like you're doing a turn-based game, so you have a little bit more computation time, I assume, than having to do this per frame. But
I still want it to happen semi-instantaneously. At least the decision, like I can tell, I can cause hang-up. Like if I run it where it does check every tile, then you click, and then there's like, even if it's just a second, you can feel the delay, like where all the animations stop and everything.
Yep, exactly.
That doesn't feel good. You don't want that. So it needs to be faster than that.
I had the same problem in Unity. I think it was my tax account, Erwin McSpender's game. So I was actually taking every single enemy, and every single enemy was like checking every other enemy, or the player was, and I was using GameObject.find, which I found out was bad because it's doing kind of like a linear time search in itself. So I was getting this exponential relationship. So it just came to a crashing halt after a while. I could definitely notice the slowdown. But yeah, that's a lot to do with in-game development, turning these problems that take linear time, the searching, and turning those into constant time. That's what a lot of people do in Unity. They take, instead of doing a game object find, which probably runs in linear time, making like a reference in your script. So you just pull it in. So then you're directly referencing it in constant time.
Yeah, and also being able to tell in your own programming when to stop. That's a big one too. Like you want to find a true case, but whether or not you need to find all the true cases or if you can just go with the first true case you find can save a lot of computational power if you know. I mean, there's a lot of, I guess it depends on when you're evaluating decisions. Which I guess I'm just kind of calling behavior.
Yeah.
AI behavior. Like if I want my thing to attack the closest player, or if I want him to actually evaluate 6 different players he can attack and decide which one. Or I'm kind of dealing with that with the tower defense too. Like when there's enemies in range of the tower, how you attack the one that's furthest along the path, or do you attack the attack that hits the most enemies?
I think you just got to find out what's fun. I mean, I really like Dynasty Warrior games, and a lot of people hate Koei Dynasty Warrior games. I was like, hey, I just like slashing a bunch of idiot soldiers out on the field, although they just like walk up to you and just like get slaughtered. But yeah, very interesting. Yeah, you're talking about when to stop. That reminds me, I've heard a lot about halting problems. That could be something totally unrelated, something I need to look into. But
well, if you've gotten back 20 true cases or whatever after your first pass, is that enough to use those 20 to decide what to do, do you really need to go find out if there's a 21st or a 22nd?
Yeah.
If it's going to have to run, like when you're dealing with factorials, I mean, like, how far is enough?
Yeah.
And with our computers, maybe, 3 or 4 is enough, and that's and go from there. But 10 years from now, maybe you could say, just go ahead and find 50 because it can do it in a millisecond.
Exactly.
So there's no reason not to.
Yeah. Because sometimes it's like, hey, you just want to pick the first one, first valid move and go. But sometimes it's like, hey, that could be leading your character to the slaughter there.
Well, yeah. Well, I guess in your Tic Tac Toe example there, it's like, do you really need to look 4 moves ahead in a game of Tic Tac Toe to decide a weight? Or is 3 moves ahead, or is 1 move ahead enough? Like,
yeah, I think it's
you can look at the current one, and that takes however many processes, and then you can look at 1 move ahead is so much more than that. But
yeah,
well, you got to kind of evaluate. The tic-tac-toe is not very complex. You could look 8 moves ahead the whole game and evaluate a decision based on the whole outcome, or just 1 or 2. I mean, how.
It's like, if I found the case where on the next move, if I don't put an O here, or if I don't put my X to block the O's, that case would be like infinity. It's like, okay. So then once you get it to infinity, which I don't know, I think Unity may have an actual concept of infinity. You might call it 999 or whatever. Might put a bool or something to make it infinity. But it's like, okay, I just need to stop here because nothing's going to beat infinity.
Yeah, no reason to check the 3rd or 4th move after that if the game is over.
Yeah. But then there's the case where it's like if you have O's in the upper 3, like in a triangle, then you can lose 2 different ways. Then it's just like you're screwed. It doesn't matter what you pick because you've already lost.
Yeah.
So.
But that may not be something the next generation of programmers has to worry about.
Yeah. Yeah, I've been reading a lot about Moore's Law, and I don't know if you've heard of that, but basically
the technology doubles every couple of years or something like that, or every half the time it doubled last time or something like that.
Yeah, and I think it's really slowed down. I remember that was like a big thing in the 90s. It's like, okay, and we're really not getting more powerful. We're just adding more cores. But I don't know if this quantum thing comes out, if this quantum thing works, because basically all our computing is based on like doing timeshares. It's like you can only do 1 computation at a time unless you have multiple cores. But if if you can simultaneously do millions of computations at the same time and only evaluate it based on what the outcome is, and that could probably solve a lot of these problems. But even looking into quantum computing is like nobody can really define what it is. I've read about some algorithms that people have come out and it's like, they factored 15 into 5 and 3 using a quantum computer. It's like, that's nice, and that may build the foundation of future computing once they get quantum computers with more qubits and things like that. But yeah, very cool. Yeah, so check out Joe Miller. He's Double Square Joe on social media, doublesquarellc.com on his website. I'm Levi D Smith.com. That's my website. I'm in the middle of an upgrade, so it may be slow. I'm having WordPress issues right now. It's like I upgrade a plugin, update my Yoast, and everything starts slowing down because Yoast didn't completed in a weird state or something. So currently working on that. But yeah, you can also find me at GA Tech Grad on social media. As I mentioned earlier, you can always find the video of this on YouTube, which I recommend, especially for this meeting, because we did show off a lot of different pretty pictures and graphs. Find us on iTunes for the audio, and also Stitcher and some other places. Make sure to sign up for the mailing list for anyone out there who wants to join us. We almost always get together the second Sunday of every month. Hopefully Dylan Wolf will be back next month to present a topic. Be glad to have him back. And yeah, I think that's it. So anyway, appreciate everyone out there for listening and watching.